Okay, in this video we're going to talk about what it means to solve a right triangle. Okay, I don't know who or when this was the verbiage that was given to finding all the pieces of a right triangle, but whenever it says just solve a right triangle, what that means is that we're finding all the parts that aren't given to us, legs, angles, all of the above. So just a reminder, as we start using trigonometric ratios more and more and more, when we're doing degrees, make sure that we're in degree mode. So go ahead and change that into degree mode if you haven't already. Again, hopefully it's still there from the last two lessons. So solving a triangle right here. Solving a triangle means determining all side lengths. So you want to make sure in the end you know what all the side lengths are and angle measures. Okay, that are not initially given. So they're going to give you enough information for you to move forward with solving, but they're going to leave some of it that is not known, and we're going to find all those parts. So for example, looking at this first one, if we're trying to solve triangle ABC, it would look like we don't know what angle A is. That wasn't given to us. So in the end, we want to make sure we find angle A. We don't know what little c is, and remember that we label side lengths based off of the angles. So if capital C is this vertice right here, then the leg opposite of it is, sorry I said leg, the side opposite of it is little c. If angle A is over here, then this would be considered little a. So here's little a. So we're going to have to find lengths little a, little c, and angle A. So we've written them all right here to help us identify that's what we're looking for. And then really you can use any of the trigonometry that we've practiced to do so. So if I look at this one, first of all, this angle right here is going to be pretty easy to find just because all angles in a triangle add up to 180 degrees, and I already know two of them. And even easier, right triangles, if it's always taking a chunk of 90 degrees out, 180 minus that 90 degrees is 90 degrees. So these two we know always combine to make 90 degrees, or in other words, they're what we call complementary angles. So anytime I know one of the angles, if I want to find the measure of angle A, I'm just going to take 90 degrees and I'm going to subtract 62 degrees. Make sense? And when I do that, I end up with 28 degrees. So I know as I'm solving that the angle measure of angle A is 28 degrees. Then I move to find something else. So if I want to find A or C, remember trigonometric equations, you can find one part at a time. So let's use that as the reference angle, 62 degrees, since it's given. And we are also given the opposite leg over here, so I'm going to label that O. And let's say we want to find little a first. So that's the adjacent leg. So if I'm thinking SOHCAHTOA, I'm going to write it up here at the top again. Sine is O over H. Ka for cosine is A over H. And then TOA is the opposite leg over the adjacent leg. So notice down here I'm using the two legs, O and A. So I'm going to set this equation up as the tangent of 62 degrees is equal to 25 over little a. Now it's a solving problem like we've done in the past videos. We're going to multiply by a, right? And then essentially we're dividing that tangent of 62. This is terrible writing, but we're dividing it over here to this side, right? So little a is going to be equal to 25 divided by the tangent of 62. So just to remind you that we then go to our calculator. Oh, let me pull up that calculator app. And we would put in, making sure we're in degree mode once again, so I can check that. Degree mode, good for me. And we're going to put in 25 divided by the tangent of 62. So it looks like we were at about 13.3. Awesome. And then we can do the same thing as we're trying to find little c. So this time, again, I know the opposite side, but this time I want to find the hypotenuse. And I would recommend if I'm trying to find another side, I would use the side that's given to me, just because if I use the rounded side that I just found, that's using a rounded sign to find something that's probably more rounded. So I'm just going to use the opposite, but this time I'm finding hypotenuse, so O and H, that leaves me with the sine function. So again, I'm going to set up another trig function over here where there's room. sine of 62 is equal to 25 over little c, or the h. And again, if I divide or multiply by c, this one becomes a division problem. So c is equal to, we're going to divide the sine over. So we would divide by sine of 62 degrees. And if you plug that in your calculator, you'll end up with about 28.3. Okay, this triangle, now that we've found all the pieces, would be considered solved. Okay, let's try another one. This one, number 1 down here, says solve the triangle. So if we look at this, we're going to identify first what do we need to find. So it looks like it gives us this leg and this leg, but it doesn't give us the hypotenuse length. So the first thing maybe I want to find is little b. I don't know either of the acute angles as well. So I'm going to find the measure of angle C and the measure of angle A. It doesn't matter which order I go in necessarily, but those are the 3 things that I want to make sure that I've found when I'm done. So it looks like I know the 2 sides. So Pythagorean theorem would be really good to help us find the 3rd side. So I'm going to go leg squared plus leg squared is equal to hypotenuse squared. I get 9 plus 4 is 13 equal to b squared, so we square root. And b is equal to the square root of 13, or approximately, those little squiggles mean approximately 3.6. Now up here in the instructions, and I should have read this initially, but it says round all side lengths to the tenths place, so just for these ones, and degree measures to the nearest degree measure. Okay, just practicing doing either of those. So this one's a side length, so I'm going to leave it as 3.6. Then we find the angle measures, and this is what we practiced in our last assignment when we want to find the angle measure. So let's say I want to find angle C first. I have this opposite leg and the adjacent leg. Again, I'm going to use the ones they gave me, though I could use the B value because I just found it. So I know that O and A is tangent. So I'm going to do the tangent of C is equal to 2 over 3. And again, if we want to solve for an angle, then we use the inverse tangent of the fraction or ratio. So again, I'm going to go second tangent, and I will pull up my calculator. So second tangent gives me that inverse tangent of 2 over 3. And I end up with 33.69. So if I'm rounding to the nearest degree, that would be about 34 degrees. And again, if I want to find the other angle, or the measure of angle A, then I would do 90 minus that 34, because they're complementary, and that would leave me with 56 degrees as the measure of angle A. Okay, now I made my answer box look crazy. There we go. All right, what if it gives it to us in words instead of a diagram? So I wanted to do an example that looks like this, but this example that's written in here is madness. We need to change a few things on it, first of all, for it to even work. So this says solve a right triangle XYZ where, and we're going to change this to a Z. So cross out the Y. We're going to say Z is the right angle, okay? Y is equal to 15, X is equal to 4, and the measure of angle Y we're going to change, because it doesn't actually relate to that. We're going to change it to 75 degrees. So make those changes first so that your notes reflect correctly the work. And then it recommends we draw a diagram to make sense of the pieces. So let's draw a little right triangle. It doesn't really matter which way it's faced or oriented, but we're going to draw a right angle. And it said that Z, because we changed it, is going to be the right angle. So X and Y are the other acute angles. And again, you can label them either way. I'll put that X up here and the Y here. And then just remember, it tells me that little y, in other words, side length y, is 15. So if this is angle y, then side length y is over here. So I'm going to put 15 over here. And it tells me that little x is equal to 4. So I'm going to put 4 across from angle x. So there's all the information that it gives me so far. Then it says that the measure of angle y is 75 degrees. So I'm going to put 75 degrees in there as well. So this one gave me quite a bit of information. But the big takeaway on this one is just how to draw the picture. So when it tells you what the right angle is, make sure that letter gets put there at the right angle. The other two, it doesn't matter where they go as long as you label it after that correctly. Little lowercase letters represent side lengths, and they're always opposite their capital letter angle. Okay, once we have that, we're going to identify what we need to find. So it looks like we don't know the measure of angle X. And it looks like I don't know my little z value, right? My hypotenuse value. So little z, that looks like a big Z. It's fine. Okay, so little z, it looks like we could use a bunch of different things, right? We could use the Pythagorean theorem. So 15 squared plus 4 squared equals z squared. So that would be 225 plus 16 is 241 on the left side. And then we square root. So the square root of 241 is about 15.5. So that would be my z value here, 15.5. Now, again, you could solve this a different way. If I know an angle is 75 degrees and I know that 15 is the opposite leg and 4 is the adjacent leg, that's helpful. I could use either of those legs to find my hypotenuse. So we could choose to use, okay, sorry. Okay. So if we look at this one, I could choose to use like sine. Let's say I wanted to use the opposite to help me find the hypotenuse. So I could have, if I wanted to, so you don't need to do both, but just so you're aware, we could do sine of 75 is equal to 15 over z. And then we're just solving this. So times by z. And z is equal to, we're going to divide that sine over, and we would divide by sine of 75. And when you plug that in, 15 divided by the sine of 75, we should end up with, again, about 15.5. So either way, you can use trig functions or Pythagorean theorem. Everything is fair game at this point, as long as it's applicable. All right, lastly, let's find the measure of angle x. Again, it gave us the angle of 75, so we really just need to do, to find the measure of angle x, we're going to do 90 minus the one it gave us, 75, and that leaves us with our measure there, which will be very small, 15 degrees. Okay. Essentially, that's what solving a triangle is. So just identify the different parts of that. Once we're really good with just solving a triangle and using those ratios, then we can do problems like you're going to see on the next page. This says determine the length of the sides labeled x, round your final answer to the nearest tenth. Also round intermediate values. Okay, those are just values that it's telling you you're probably going to find a value that you use to find the next value in your problem. So we're just going to round everything to the nearest tenths. Okay. So again, if we're looking down at number 3 and it wants us to find the value of x, x represents the length of this little piece of the base of the triangle. So you've got this whole triangle, but oftentimes within whole triangles we see that we have two little right triangles. So if I want to find the value of x, and I know that this angle measures 49 in this little triangle, I just need to know this side or this side to help me build that ratio. I can't have two unknowns. So I probably want to find this side because that's a piece of this triangle. So if I find that side. So I'm going to draw these two triangles separately just so you can see them. So there's that triangle, there's that triangle. Wow, that one didn't really look like it, the other one, but there's that triangle. This one's 24 degrees and 44. And again, because I know a side length in this triangle and this angle, I can find, let's say, this value right here. I'm going to call it y. And notice that would be the opposite on this triangle from 24 degrees, and this would be adjacent. O and A is tangent. So I'm going to do the tangent of 24 is equal to y over 44. Now, again, does that help me solve for x? It does in the long run, right? And that's how geometry problems often work, and trig. So we use what we know to help us find what we need to know. So in this case, 44 times the tangent of 24. Let's do that really quick. 44 times the tangent of 24. So 19.6. Again, we're rounding to tenths. So if this is 19.6, now notice if I come up here and put this on my triangle, because it's the same thing as y, they share that side in the middle. Now I can find the value of x. So here's my reference angle. I know the opposite side is 19.6, the adjacent side is x, so I can set this up as the tangent of 49 is equal to 19.6 over x, and then again I just solve. So times by x, divide by that tangent. And we get 19.6 divided by the tangent of 49. And if you plug that in your calculator, you should end up with about 17.0. Okay. If you need to watch that one again and again to make sure we're understanding kind of how to build those two pieces to result in the one piece we want to find, I would do that. Again, number 4, I'm not going to go all the way through this one, but you can see that, again, there's a triangle over here, and I only have one of the sides that I don't know and I want to find. So again, I need to find that shared side, and you'll do that using the side that you do know. So this one would be a hypotenuse. This one would have an adjacent side. So just instead of tangent, I would be using cosine because that's adjacent over hypotenuse. Okay. All right, lastly, determine the area of a triangle. So again, this is asking you to find area. And when I look at a triangle, I know that area of a triangle, I'm going to write it right here, is equal to 1/2 the base times the height, or a lot of my students like to write it as base times height divided by 2. So if I look at this triangle, and maybe it's a little bit unclear, but the 36 represents part of the base. I don't know what the rest of the base is, so I'm going to call that x. And I actually don't know the height either, because the height is this dashed line. And I do know that that 30 degrees is this angle up here, 24 degrees over to the left. So there's some pieces that I'm going to need to help me find the area. I need the base. So looking at this, I need to figure out what x is so I can find the whole base. I also need the height in my formula, so I do need to find that as well. So that's where the trigonometry is going to come in to help us do that. So let's just look at this left triangle. So if 24 is my reference angle, and I want to find the y value, I'm going to find side opposite, and it looks like I know the adjacent side. So again, this one is going to be O and A, which is tangent. So I'm going to do the tangent of 24. It just so happens the ones I'm choosing are tangents, but they don't have to be. Tangent of 24 is going to be y over 36, O over A. So we go ahead and solve by multiplying by 36. So y is equal to, again, we're going to do 36 times the tangent of 24. And if you do that in your calculator, you should end up with about 16.0. Okay, so if we know that this one is 16.0, that will help us with the other one. So that triangle looks very squished there. I'm going to write it just over here. So I'm just removing that over here. So this is what we want to find. We know that's 30 degrees. And we've got 16.0 here. Now this is a special case triangle, so if you want to do it that way, you can. Or again, just use a trigonometric function. So if I know this is my reference angle, this is leg opposite, this is leg adjacent, so again it's tangent. So I'm going to set this up as the tangent of 30 degrees is equal to x over 16. I then go ahead and solve by multiplying by 16, or 16.0, same thing. So when I multiply that, I end up getting 9.2. Okay, again, that's a calculator thing. So if we go here, I could put this in each time. Hopefully we're getting comfortable with this. 16 times the tangent of 30. So that would be that 9.2. Very good. Okay, so that's some of our information. I don't know why I boxed the y value just to show you that's where it was. But again, in the end, what we do is we want to find the area. So the area is equal to the base. Now the base up here is 36 plus, right, this 9.2 we just found. So 36 plus 9.2 is 45.2 times the height, so that was our base, times the height. Oh, lots of parentheses going on. And our height there we found was 16.0, or just 16, all over 2 using that formula that we talked about. And again, once we plug that into our calculator, we find out that the area would be about 361.6 units squared. And this one doesn't give me units, so I'm just going to write u squared. That just helps me know that it's area because the units are squared units. Okay. Again, you're going to practice just a couple of these, and we'll just keep practicing using trigonometry within other types of problems. So this one is definitely an area problem, but we are using trigonometry to help us find the necessary parts to find the area.